Hey guys, welcome to another GIS Python tutorial. So today in this tutorial we're going to cover how to subtract two digital elevation models, and you can do this with any two rasters. And we're also going to we're going to start using some better programming practices, so using functions and things to keep our code nice and neat. So let's go ahead and open up our Python console in QGIS. Open up the editor, and we will start a new script here. Okay, so we're going to make sure we have GDAL imported, and we're going to need two file names here. So this is going to be, we're going to need three file names actually. So our first one is going to be the first raster, temp elevation ned10m.tif, so that's the raster I've been using. fn2 equals c temp elevation ned10m altered.tif. I'm going to pull these two files in just to show you what we're looking at. I'm going to go ahead and close this real quick, go to my browser, and I have these two right here. Let's add them in. I'm going to pull up the value tool so you can see the difference between them. So you can see that the altered in these higher elevations, it's greater than the original, and in these lower elevations, it's less than the original. I just applied a kind of nonsense algorithm on there. By nonsense, I mean it doesn't mean anything. I just did it so we could have two layers to subtract and see a difference. Okay, so we have those two there. Let's open our console back up, and then we need an output file, and I'm going to put this in the same folder, and we'll name it subtract.tif. Okay, all right, so the first thing we need to do, we need to open our first, second rasters, and then subtract them and save that to an output raster. So the first thing is going to be to open those. So if we're going to do this a couple times, I'm going to make a function that does this. And the way I make a function in Python is to type def, whoops, not derf, def, and then the name of the function, we'll call it open raster. Then I'm going to give it the parameter, it's going to take a file name. And what we're going to do is do GDAL. I'm going to make a data set equals GDAL.open fn, and then we can return ds. Okay, and we're going to put some things in here just to make this a little better. We're going to put access in here. We're going to set it equal to 0, and access 0 means that it's read-only, and so we're going to come down here and put this as access. If I want to make this an update or be able to change the data set, then when I do this, I'd put a 1 in there, and I'll show you how that'll work here in a minute. And then the next thing I want to do, if ds is none. No, we're good. Yeah, we'll do if ds is none. Then we're going to print error opening raster data set. Okay, and then we'll return the data set. So this way we'll know if there's an error, and that will happen if ds is none. So there we go. Okay. Now once I have a raster, the next thing I want to do is get a raster band. So let's do def get raster band, and we're going to have to give it a data set or a data source. We're going to have to give it a band number. And we'll set this equal to 1 for now. When I set these equal to 1, it just means specify it here, so I don't have to pass the argument. But if the argument's different than the value here, then I need to pass it. Okay, and so the way we're going to do this is we're going to do band equals ds dot get raster band dot read as array. Okay. So there we go. We've got that, and then we need to return band. Okay. Now you're asking me, well, I have to write this anyway, and once the data set's opened, it takes one line to open the data set, and it takes one line to get the band. How am I saving myself any code here? Watch this. Here's what we can do. If we change this actually to a file name, and then we do ds equals open raster fn and then we need to give it an access. So we can put access here also. Okay. Now we can return this. So now it takes one line of code to get the raster band instead of 2. Okay, so let me show you how this would work. Oops. So to run our code here, we'll do, so let's do data from raster band 1, dat1 equals get raster band. We're going to give it fn1. We're just going to use the first band. We're going to use read only. Dat2 equals get raster band fn2. Okay. Now we can do dat out equals dat1. Let's do dat2 minus dat1. Okay. So now we already have our data. It was really simple. We have an array here, a numpy array here, a numpy array here, and we have our output numpy array here. Now, all we need to do is write a function that takes our array and saves it as a new raster. And if you'll remember in a previous video, we've already learned how to do that, so we'll just write a function that kind of streamlines things. So let's do def, let's do create raster from copy. And so we'll give it a file name for the new raster. We want to give it a data source to copy from. We want to give it the data. That's the new data we're going to write. Okay, so colon, and oh, we also need to give it the driver. Yeah, the driver type. So this is going to be, we'll make this GTIF by default. Okay, so now what we want to do is we want to do, actually I'm going to name this, I'm going to put this driver name, actually driver format, FMT, driver format. Okay, so now we're going to do driver equals GDAL get driver by name, and we're going to give it driver FMT, driver create copy. Okay, and now here's where we can put in the information that gives us that new raster. And so here we just need to give it the file name that we input, so that'll be the new file name, the data source or data set to copy, and then I'm going to give it the strict equals 0. And we're going to call this the output data set. Okay. So now I've created that data set, and now we need to go out ds dot get raster band 1, and now we need to right array. And here is where we're going to give it the data to write. Okay, so now we've created that data set, and now we can either return out DS, or we can just set it equal to none, and that will close it properly. Okay. I'm going to check and make sure I've done this correctly. Okay, this should be correct. So now what we need to do is just call that function. So now we need to say create. Oh, man, I forget what I called it. Create raster from copy. So we're going to give it fn out. Oh, we didn't actually save a data source here, so we need to actually input a data source. And we can do that by calling GDAL open, and we can give it fn1. Okay, so that's going to send it a data source. And then our format's correct. We don't need to put a format in because it's already specified as GTIF. And we probably just want to close the data source we pass in to be safe here, especially since we passed it in as a function. Okay, so now if I've done this correctly, what should happen is I should create this new difference raster. Okay, so let's go ahead and click run and see if that raster shows up in my files. Okay, and we have an error here. Line 10. Oh, and it looks like it didn't close my quotations. Let's click run. Another error. This one's in line 28. Oh, I didn't give it the data. So this is going to be dat out. Okay, so let's go ahead and click run script again. And hopefully we run correctly. Let's see if that data popped up. So here's a subtract.tif, just what I named it. Let's add it in and see if it looks right. So I'm going to go ahead and close this out of the way. Let's add subtractive in. And let's go look at our layers. Okay, and look at that. So these are definitely different values. So let's go in and let's change our symbology on this. And let's go single band pseudo color. Let's change this to like a red, blue, so we can see the difference between negative and positive values. Man, I want to really decrease the number of classes here. Clip out a range of values. Let's apply that. Okay, now we're going. Now we're moving here. Okay, so let's just adjust this so that this one is 0, and that will give us the white will be 0 change, and then we'll get these values elsewhere. Okay, here we go. There you go. So you can see here that we get increasingly negative changes, we get lower, and increasingly positive changes, we get higher. And I just took kind of the mean elevation of this raster, and I multiplied it by some constant if it was less than the mean, and by some constant if it was greater than the mean, and there we get these differences. And so that's what it is. You can look at our value tool over here, and you can see that the difference between the two, the subtract, is equal to the difference between the two. Okay, so that's how you can subtract two DEMs. I'm going to show you one more thing here. Let's go back to our Python console. So now I have these functions: open raster, get raster band, create raster from copy. What I can do here is I can actually make a new function, which is def subtract rasters. And I can just give it file name 1, file name 2. And here, I can copy this code, and we'll just get rid of it. Come down, paste it in. I'm just going to tab these over. Okay, so now what I have here is I have a function for subtracting rasters. And all I have to do is call subtract rasters here, give it fn1, fn2, fn out. Oh, we have to add fn out up here. Okay, and I've specified those file names, so I'm just going to grab these and put them down at the bottom so we can visualize this a little better. Okay, and now that I've written this code for these functions, if I wanted to do this again, I could write, I have basically 26 lines of code that works out those functions. And if I want to do that again, instead of writing 26 lines of code, I can write 4 lines. Give the file names and then type subtract rasters. So I'm going to just come and remove this one. And we'll just run this again just to show you that it works. Okay, so let's go back to our, actually, what we can do is we can do iface add raster layer fn out. Okay, and so now when we run this, we'll add it right in. Okay, and I'm going to close this, and there you see our raster layer, which is our subtract. I didn't change the symbology in the script, but there you have it. So that's how you can really make use of functions and how you can subtract to DEMs. I'll just point out real quick one more time that if you wanted to add another function, you could add a function called subtract symbology, and then you could call that and give it your output raster, and it would symbolize that like in the manner we did earlier. But anyway, that's how you can subtract rasters and how you can organize your code in a more clean way. Hope you enjoyed the video, and thank you for watching.